I was falling asleep in the last class. I'm hanging on by a thread.
All right. Do your best. Okay, so last class we were doing a word problem that I had put up on the board. We had tried graphing quadratic functions. That was pretty much what we had done, but I had not given us a word problem. So the problem I gave you was a company makes digital cameras and gave you a price-demand equation or a price-demand function and gave you a cost function. Now, did I write down the list of questions or just these? Okay, so the first part, I think I call it part A, was find the profit function. Wait, what was it? Find revenue. Then what? Find profit and then graph it?
C is graph.
Yeah. Graph profit. And then from the graphing, we're going to find break-even points where profit is positive and negative. All right, so first step is to find the revenue function. So also last class, I gave you a formula for revenue. I said that it's going to come up now quite a bit. Remember that formula? Revenue is X times, not profit, be careful. Remember I said lowercase p is your price demand, uppercase P is your profit. So revenue function, I should write R of X as a function, is going to be X times your price demand function. All right, so I'll use this notation instead. So all we have to do is take our price demand function and multiply it by X. So I'm going to take X times, in parentheses, 94.8 minus 5X. And then I'm going to distribute the X through. All right, so multiply here, here. So we get a final revenue function of 94.8x minus 5x squared. And you can see here we have a quadratic function, don't we? The revenue is quadratic.
I'm lost right now. I'm sorry.
I know, well, were you here last time? No? Oh, well, then. Yeah, you're going to feel lost then. Yeah, watch the video from last class. You'll feel better. I don't know if you'll feel better, but at least you'll understand what I'm talking about. Okay, so we have a quadratic, right? And we could graph this, couldn't we? I mean, if we were asked to graph this quadratic function, we could. But not yet. That's not what we're doing. Part B says to find the profit function. So what is profit? Profit is revenue minus cost, right? That's your profit. So my profit should be this function here minus my cost function, which is here. All right, so we have profit, capital P of X, is equal to the revenue R of X minus C of X. So profit is revenue, which we just wrote down, 94.8 x minus 5x squared. And then we subtract from that C of x, which is the 156 plus 19.7x. 156 minus 19.7x. Is that correct? Is that right? Got the revenue, and then I'm subtracting the cost. Is that correct? It's not correct. Thank you. Parentheses. Okay, you must have this in parentheses because you're subtracting the entire cost function, right? And if the cost function has two pieces, you need that negative sign to pass through to both pieces of the cost function. So if you leave the parentheses off, everything's going to be off. Understand? So let me try and put my profit function. I'm going to distribute that negative through. Minus 156 plus 19.7x. All right. What type of function is that? Our profit function. Is it a line? Is it a parabola? What is it? It's a parabola, right? So I'm going to get my calculator out. I noticed that I can combine some like terms together. I have these two are like terms, 94.8x and 19.7x. So let's add those up, 94.8 plus 19.7, 114.5, yes?
So that equation that you put in the, that right there, is
Yes.
it supposed to be plus already and then switch to?
Was it plus in the formula? Oh, wait a minute, hold up. Oh, that's why y'all were telling me it was right. Because I wrote the cost function down incorrectly. Thank you for catching that. It would have been a disaster. Do y'all see this should have been a plus?
Yeah.
Okay. This was plus because, look, it's a plus here. Right? And then when I distribute the negative, this should be a minus. Okay. How many of you saw that? Huh? Just say something next time. Good job. Thank you. All right, so this will be a minus, two minuses. So I need to do this on my calculator. 94.8 minus 19.7, 75.1 x's. All right, so I'm going to write down this function. I'm going to write it in what we call descending order, which means I'm going to start with the highest power of x, which is negative 5x squared. And then I'm going to do the next power of x, which would just be x. And that's what I did on my calculator. I got 75.1 x. And then minus 156. And that is my profit function. The answer to the part A was my revenue function, which was this. Any questions up to this point? We're good? Now, graph the profit function. That's our next task. So before I gave you this word problem in class last time, we graphed a quadratic function. And the one I gave you was very nice. The numbers worked out great. The arithmetic was clean. This problem is going to require that we use our calculator and that we're careful. All right? So you all ready? Well, it doesn't matter if you're ready. We're doing it anyway. All right, here we go. Part C. Graph. I'm going to write the function here. P of x equals negative 5x squared, just rewriting it, plus 75.1x, and then minus 156. Make sure I copied it down right, because I've already made a mistake today. I think I've got it. Now we go graph this. So what did I recommend you do first when you go to graph this, a quadratic function? That will come. It wasn't the first thing I looked.
See if it goes this way or
Yeah, see if it goes up. You weren't here. What are you talking about?
It's a negative on the slope. I mean, that's
Okay, all right. I'm just messing with you. Okay, so the first thing is to determine if the parabola opens up or down. Okay, that's our first step. All right, so first step, let's ask ourselves up or down. And in this case, it's going to go down. So I'm just going to draw a little picture of what it should look like. And why is it that it's going down? Because we have that A is negative 5, which is less than 0. So because this is negative, right, the number in front of x squared, we call that the coefficient. So the coefficient of x squared is negative, so the parabola opens down. All right. Now that we know this, we know that vertex will be right there, right? So this function will have a maximum or a minimum? A maximum. So that means that there's going to be some point out there that gives us maximum profit, right? We're going to want to figure out what that is at some point. What's step 2? What is the second thing I recommended that you should do when you're graphing a quadratic? That is coming. The vertex is the next thing I suggest you do. All right? So we're going to get the vertex. And do you recall how it is we find the vertex? Yes, I gave you a formula, right? The formula that I gave you was that we're trying to find this point right here. That point is the point HK, right? And the formula for it is that H is always negative B over 2A, and K is f of H. So you calculate this number, and then you take that number and you plug it into the function. Now I didn't do this, but let's identify A, B, and C on this quadratic. We had not done that before. This number right here is A, right? This number right here, positive 75.1 is B, and negative 156 is C, right? We're going to need all those numbers in this problem. So what is negative B over 2A? Don't do it on your calculator yet. Just tell me what it is if I replace that and that. Negative 75.1 over 2 times negative 5. Now, if you're going to type this all in on your calculator, I wonder if anybody types this in. Let me see. And gets 7.51. If you get 7.51, does that seem right? Yes? No?
What was that K equals f of H?
Pardon me?
That K equals f of H?
We haven't done this yet.
Oh, okay.
We haven't done this part yet. We're just getting H. So negative 75.1 on top. You have to do 2 times negative 5. That's negative 10. Do that on your calculator, 7.51. We should get 7.51 for H. Now comes a part that's a little harder than what we did last class. We have to take this decimal, 7.51, and plug it back into the profit function. That's what this means. Now I use f here. This just tells you in the formula you're going to plug this answer into whatever function we have. So for us, we're really, K is really the profit function, which is the one we started with, evaluated at 7.51. So do you know what I'm saying? Like in the past when I've given you functions and asked you to plug things in, I've always given you nice numbers. I've always given you like plug in 2 or plug in negative 3, and it's never been a decimal, but now it is. All right? So here's what I have to do. Negative 5, parentheses, 7.51 squared plus 75.1 times 7.51 minus 156. So remember, we're going to have to square the 7.51 first on our calculators, then multiply that times negative 5. Do 75 times 7.51, figure out what that is, subtract 156, and we're going to get some number here. So I'm going to show all the little details. If I square 7.51, I get 56.4001. Let's just round that like 2 decimal places. Negative 5 times 56.4, I'm going to say 40, plus I'm going to do 75.1 times 7.51. These two together give me 564.00. There's a 1 after that, but I'm just going to write that. And then minus 156. Everyone understand what I'm doing? I would encourage you, if you have your calculator, to do this also, because you don't want to be doing this for the first time on the test, right? Like the first time you're ever using your calculator to do this. What do I need to do next? I need to multiply this -5 times this, right? So let's do that. -5 times 56.40. I get -282 plus 564 minus 156. So these numbers actually turn out to be pretty decent, yeah, the way they round. Now I do that on my calculator. I get 126. Okay? Any questions here? All right, so my vertex. Remember, my vertex is a point on my graph, right? It's actually that highest point. And that highest point occurs when the x is 7.51 and it spits out an answer of 126. We good? All right. Okay, now, next thing. X-intercepts. Let's go after those now. I have my vertex. Let's go find my x-intercepts. I'm going to just erase this. I'm going to put the vertex back up here so I can refer to it in a second. So third step, x-intercepts. And how do we find the x-intercepts of a quadratic function? That's y-intercepts. Did you say plug in 0? Yeah, that's y-intercepts. X-intercepts, set it equal to 0. Good. So we're going to set the actual function equal to 0. And this, my friends, I'll call you friends even though we're not friends. This, my friends, sucks. This is a quadratic. It's got decimals. And, you know, sometimes life just kind of sucks a little bit. We've got to work with decimals, all right? So your options, do you remember what your options are for this? I gave you two options in class last time when you have a quadratic equal to 0. Factor, and if that fails, quadratic formula. So I think we're going to need to do the quadratic formula here. So let's write the quadratic formula. The quadratic formula says if you have this, then x equals -b plus or minus the square root b squared minus 4 times a times c, all of that divided by 2 times a. So this is where all these little numbers are going to come into play. A, B, and C. They all get plugged in here. So let's do it. What would -b be? What is -b? -75.1. So this is going to be -75.1. That's this. Plus or minus square root. Now, what is b squared? So you have to take 75.1 times 75.1. I think I brought a real calculator just because I knew we were going to be doing this. We did that earlier. No? No, we didn't. 5,640.01. So we're going to have 5,640.01 minus 4 times what's a? -5. Be careful there. -5. And then times c, which is -156. Got to get the signs. Make sure you don't mess the signs up here. And then all of this over 2 times -5. All right. Now I know I've talked about this before, But this is the point where most people make mistakes with the quadratic formula. The computation of these three numbers. So what I have always recommended is that right after the minus sign, you just take these things right here and you multiply those together. So like 4 times -5 times -156. Will that be a positive or a negative? The numbers that I get from this blue box. It'll be positive, right? So go ahead and do that. Let's get on our calculators. Do 4 times -5 times 156. I get 3,120. So here's where I am. X should be equal to -75.1 plus or minus square root of 5640.01 minus 3120 all over -10. So these three numbers turned out to be positive, but remember we're subtracting. So that's why I still have a minus here. And I think because this is going to be estimation here, why don't we just round this? Are y'all okay with us rounding this to 5640? Just to make it a nice number. It's not going to matter. We're going to take the square root in a second anyway. So it's probably going to still be a decimal. But okay. X equals -75.1 plus or minus square root. Okay, do 5640 minus 3120, and you get 2520. So square root of 2520 over -10. Now we have to take the square root of 2520. So square root, you know how to do square root on your calculators? If not, you need to learn. I get 50.199, something like that. So I'm going to say 50.2. And at this point, the square root's going to go away, right? Because we took the square root. So we have x equals -75.1 plus or minus 50.2 all over -10. Y'all still good? Now we can go and get the two answers. Remember, these are x-intercepts. We should probably have two x-intercepts here. How many can you have with quadratics? You can have two. You can also have one, or you can have none, right? The reason why I like to do it in the order that I did this just now, like, you know how I started out up, down, and then I went vertex? Because in a normal college algebra class, the next step I would tell my students to do is to draw a quick sketch. Like, where's our vertex? 7.5 and 126. Doesn't that mean to the right and up? So like I have a vertex up here, right? And it opens which way? Down. And from that quick picture, I know I have two x-intercepts. In a normal college algebra class, I would do that. Here, I'm not asking you to do a quick sketch. All right? We're just going to go after the x-intercepts. All right, so now I like to do two separate little arrows here. This is going to be when I use the plus. This is going to be when I use the minus. So -75.1 plus 50.2 all over -10. And then -75.1 minus 50.2 all over -10. And let's see what we get. Do everything on the top first, right? I'm getting here, anyone have this one yet? About 2.49? 2.5 if we round it. So about 2.5, it's good. And then what about this one? It shouldn't be exactly. What do you get? Negative what? 12.5. Negative 12.5?
No, just 12.
Oh, negative 12.
No, just regular, just
Just 12.
normal, just 12. Negative, just.
Just 12. Okay, sorry. 0.53?
Yeah, 0.5.
Okay, 0.53. All right. Those are our two X-intercepts. All right, let's go back over here and let's write those down. Remember, the X-intercepts are points on our graph, aren't they? So if I were to graph these 2 points, here they are. I would have 2.5, 0, and the other one 12.530. Those are our two X-intercepts. What's the fourth step? Not yet. Now your Y-intercept. Now your Y-intercept. So we should have one Y-intercept. I don't think I mentioned this in class last time. For every parabola that opens up or down, you will have one Y-intercept guaranteed. All right? So to get this, what we do is we plug 0 into the function. This is always easier than the X-intercepts, because all you're doing is replacing x with 0 in the function. So what happens if I put 0 here? That's gone, right? 0 here, that's gone. So what do you get?
Just the line, isn't it?
Just this number, right?
Yeah.
Negative 156. And so as a point, this is the point 0, negative 156. All right, there we go. All right, we're ready to graph this. We have all the information we need. We're going to draw a picture that shows our profit. Here we go. I'm going to need an x-axis and a y-axis. Now, how far out on the x-axis should I go? Like how far left and right? What's the furthest I'm going to need to go here? Yeah, 13 or 14, because look, the x-intercept here, right? Go back to the original word problem, though. The original word problem. Do you remember what I said x had to be between? 1 and 15. Do you remember that? 1 and 15. So I'm actually going to go out to 15. So I'll count by 5. It's 5, 10, here's 15. And we could even break this up. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we could mark them all out. There's 15 units. Now, how about the y-axis, which is actually the graph of the profit, right? This is the profit up and down. So look at your graph. What's the highest point that you have? 126. Remember, we have a maximum, don't we? So 126 is the highest we need to go. And we actually have a y-intercept that's way down at negative 156. Don't we? So why don't we go 200 each way? That sound fair? All right, so what I'm going to do is this. I'm going to say this is 100, and that's 200. This is negative 100 and negative 200, just to get an idea of scale. And now we start plotting all of our points. And we will start with the first thing that we got, which was the vertex. So I'm going to draw this in red because this is not going to be my final picture. 7.51, 126. So that means to the right, 7, here's 7.51 is about right here. And I go up 126. What's that right there is 150, right? Right here. So that's what? Hello? 125. So isn't that like good enough? Somewhere, sorry, let me see. Somewhere around here. Does that seem to you close enough for 7.51, 126? All right, okay. Now, the next two pieces I have are the x-intercepts. These are going to lie on our x-axis. 2.5, 1, 2, 2.5 right there. And then 12.53. 12 so this is 10, 11, 12.53. Again, kind of, about here. Does that look right? Yeah, it looks pretty symmetric. Remember we have that axis of symmetry from last time? That when we draw this, it should be the same on both sides? Okay. Some things that you should look for when you're doing these problems, like warning signs that something is wrong. Like what if your vertex was over here, but your two x-intercepts were over here? Do you see that that's like a problem, that it's not going to look like a parabola if you try and draw? So that would be kind of a warning that you should go back and just look at your arithmetic again. Something went wrong. Last thing to get is our y-intercept, and that's about negative 156 somewhere in here. And now I'm going to draw a parabola through these. And I always like to start with the side that has the y-intercept. I'm going to make this nice and curved, like that. And then over here, like this. Good? This continues down, doesn't it? Now that is not the graph, the final graph of my profit function. Because the way I drew it right here, I have not taken into consideration the restrictions on x. X had to be between where and where? 1 and 15. Didn't it? So what I'm going to do now, this will be kind of my last step, is I'm going to figure out what is my profit at 1 and what is my profit at 15. So I'm going to plot right now what we call the endpoints. So I want P of 1 and P of 15. So you get to plug 1 in and you get to plug 15 into that. And that's going to, again, be something you can do on your calculator. So if I plug in 1, that's pretty nice because it's just going to be negative 5 plus 75.1 minus 156. Negative 85.9. Let's just round that to negative 86. And then if you plug in 15, this is going to be a little bit harder. You just have to make sure you square that 15 before you multiply it times negative 5. And why don't you go ahead and work that out, whoever's got a calculator, and then we're going to make a final analysis here. Anybody have it yet? Anybody getting negative 154.5?
Yes.
Yes? Okay. So negative, I'm going to say about 154.5. So you would plot those points now. These are 2 points, right? This point right here, you plug in 1, you get negative 86. This one right here, you plug in 15, you get negative 154.5. That's good enough. All right, so let me try and put those on here. What's that? Whoa, what's it doing? do you zoom out? Well, I did that. Oh, Control 0 didn't work. Maybe number lock's on. Control 0 is usually what I press. All right, so when I plot these, 1, negative 86, it's going to be about right here. So 1, negative 86. And then at 15, I'm at negative 154. So down here, 15, negative 154.5. Those are the ends of my profit function. So my profit function is actually just this right here in blue, like that. Now I'm going to label my X-intercepts. This was, I erased it, was it 12.53? 0, and then this one was 2.50. All right, so do y'all understand that the blue is our answer? That's our profit function. I'm going to draw two imaginary vertical lines at 1. Okay, I'm just going to put this here for reference, just to show you something here. And then over here at 15, oh wow, I didn't line that up very well. That point's supposed to come down a little more. It's not perfect. Okay? All right, let's try and understand what this function is telling us. If we look anywhere in this region right here, what's happening in that region? Your profit's what?
Increasing. Or it finds it's like, I guess it's cap.
Look, this is where your profit is 0, right? Yeah. Your profit is 0 at 2.5. If you manufacture and sell 2.5 cameras, which you can't really sell 2.5 cameras, but if you could, then your profit would be 0. Here, again, if you manufacture 12.5 cameras, your profit will be 0. So what about if I do anything in between? What will my profit be? Greater than 0, which means positive, right? So basically, you're making money in this region, aren't you? Here, in here, your profit is positive. Capital P, not little p, right? What about in this, and I should have done this in green, because that means you're making money. You're in the green, or black, it doesn't matter. Now what about here in this region? Or in this little region right here? Now you're losing money, right? Here, your profit is negative, because see, your graph is below the x-axis. That means you're getting negative output. Here, your graph is below the x-axis. You're getting negative output. Understand? But the most important point to us is this one, because this right here is where we would get maximum profit, right? Max P right there. Now, can you tell me what the maximum profit is? So what is max profit? What is it? It's 126. Now, in the word problem, this was in dollars. The price demand was in dollars. So unfortunately, I mean, that's not a lot of money, but it's still money, right? So the maximum profit is $126. How many cameras must we manufacture and sell to make the maximum profit? How many cameras?
7.5.
Yeah. Be sold to maximize profit. So you get 7.51, which doesn't make any sense. I mean, in the real world, right, we're not going to have 7.51 cameras. But if you did 7 cameras or 8 cameras, there wouldn't be much of a difference in the profit. 7 cameras would be to this side over here, and 8 would be to this side. So either way, about 7 or 8 cameras will maximize your profit. Make sense? If I ask, when is profit positive? If I ask, when is the profit positive, you would tell me what? Between 2.5 and 12.5 cameras. If you sell between 2.5 and 12.5 cameras. Now this is the same thing. 2.5 cameras you're not going to sell, but it gives you some range, right? These are models in a business, and they're not perfect, right? So we would say, hey, we need to stay between like 3 and 12 to be making money. All right, last thing, what are our break-even points?
2.5.
What are break-even? The break-even points are where you get a profit of 0, right? So these are your X-Intercepts. So you'd say 2.5 or 12.5 cameras. And that's pretty much it. So what, that took us like 45 minutes? Just about? Almost?
There's going to be a test for there's going to be a second test?
That'll be on the second test, yeah. Just one problem? Just one problem? It'll probably be a very small number of problems on this test, yeah. Because it's going to take you a little while to do it. But you need to understand what you need to do, right? All right, so that's it. Now, I turned on the projector because I wanted to show you something. We have all these computers in this room, and I believe they work. We'll have to double check. But on the test, I would like to allow you to do some of these problems using technology. Like, I'm going to force you to do one by hand. But then I might ask you some other questions where you have to use technology. So, for example, everyone probably wants to write this down. Wolfram, I talked about this before. Wolfram alpha. Okay, Wolfram alpha, W-O-L-F-R-A-M alpha, A-L-P-H-A. If we go to Wolfram alpha, and if we just type in that profit function right now. So the profit function was a -5 x, squared. And notice I'm using this little, what we call the caret key right there for raising something to a power. Right, so if I do that, and then what was it? Plus 75.1x minus 156. So if I just type that in and I hit enter, it's going to graph this. Okay, do you see this graph here? Let me zoom in a little bit more so you can see this. It's graphing it right now from 1.5 to 13.5. If we come back up here and we say from, where did it start? 1, 2, 15. Let's see if it's smart enough to understand what I just said. Yeah, it is smart enough, but it looks like it's 0 here, but that's actually 1. Can you all see that? because it's counting by, what are these counting by, like 0.5? So this is 1, 0.5, 2, 0.53, 0.54, 0.5. Get it? So there's your graph. Ooh, but I don't like what else the other stuff it did. Boy, that didn't give you anything other information. So let me take that back out and graph, because it gives us the X-intercepts here. See, they call them the roots. Where are they? Whoa, stop. See the roots? 2.49, we rounded it to 2.5, and 12.53. Now what about the maximum? If you scroll down here, do you see this global maximum? See that? It's actually, they don't round it. They don't give you the decimal, but if you got on your calculator and you did 252.001 divided by 2,000, you would get, what did we have, about 120, what was it, 126? 126 here, and if you divide that, you're going to get 7.51. So that's your vertex right there. Do y'all see it? And then the Y-intercept, it's probably not going to give us the Y-intercept, but do y'all agree the Y-intercept's pretty easy? Just plug 0 into the function? So what I'm getting at is that on the test, I would like to give you a price demand and then a cost function, and then ask you the same questions I just asked you, but say go to Wolfram Alpha and get the information. All right? You think you could do that? We'll practice one. Maybe not today because I haven't made sure these computers are on. All right. See, make sure I've got everything I want to talk about here in this section done. Okay, I've got another one here. Okay, do you know how we just had, we had a revenue function, and it was 94.8x minus 5x squared, and then we had a cost function that was 156 plus 19.7x. Right? We had that. And from this, we created the profit function? Yes. Right? Okay. The book also talks about how you can graph each of these separately. All right? So I'm not going to show all the little details. I want to leave this up here. If I were to graph, let's start with this first. The cost function. If I were to graph that, what would it be? What would it look like? A line, right? A line. What would the Y-intercept be? 156. And then the slope would be 19.7. So if I graph that, let's just say this is 100, this is 200. It would start at like 156, and it would go like this. Do you all agree that that would be your cost function right there? Roughly speaking, this is your cost. Yes? Roughly? Now, if we graph this R of x, that's what if we graph it? It's a parabola. Which way does it open?
Downward.
Downward, right? And then you could find the vertex and do all that, right? Yes? It's downward because of the -5, all right? So if I graph that, and I'm not going to go through, well, what's the Y-intercept? Do you know the Y-intercept of this? 94.8, because if you plug in 0, you get, no, wait, 0, sorry, it's down here, right here. Then if we graph this, and again, we would have to go through all the details, we would get something like this, okay? So the book talks about doing that, graphing them individually. And then it asks, what's the significance of those 2 points? This is your revenue function. The blue is your cost. It's the what? Yes, okay, I see what you're saying. But I'm asking about the significance of these 2 points. I think you're talking about like this part right here. These are your break-even points, right? Because this is where your revenue and cost are the same, right? These 2 points are your break-even points. And then this region in here is going to be your profit area. So from here to here, your profit is this region. Now, I don't like this approach, and here's why I don't like this approach. If you were to do this, these two points where they hit each other are identical to these two, all right? They're the same 2 points. It would be 2.5 and 12.5. Also, here we can get the maximum profit, but over there you can't. All right, so I don't like this way. I do not like to graph the revenue and costs separately and look at that graph. I like to create the profit function and graph the profit function. Right? Remember, profit is revenue minus cost. So I'm just taking the red function, subtracting the blue function, and that creates this one. So on your homework, I want you to skip 51. Number 51 asks you to do that. I don't need you to do that. All right, we've got a little time, so let's start the next section. All right, so before I start it, I want to give you a list of the types of functions we study in this class. All right, first type, linear functions. This is something like f of x equals mx plus b. That's like y equals mx plus b. We should all at this point be comfortable graphing a line. Someone gives you that, you can find the y-intercept, use the slope to graph it, you get 2 points, draw a straight line. The second type of function that we study in here is the quadratic. This is a function that looks like ax squared plus bx plus c. And after what we talked about today and last class, we should all get to a point where we're semi-comfortable graphing a quadratic. All right? We understand there's a lot of work to do that, right? All right. There are more types. The next type is called polynomial functions. And that's what we're about to talk about. So I'm going to leave that as a question mark. After that, rational functions. We'll talk about that. After that, there's exponential functions. And then finally, logarithmic. All right, so we have knocked out 2 of the 6. All right, we want to get semi-comfortable with these because all of these will come up in the next class, Math 1325. But in that class, you'll be doing calculus to these functions. You have to be somewhat familiar with these, though. All right? Now, why are there 6 different types of functions? I mean, why do we have to have so many? And the answer to that is because every real-life situation is different. when you try and make a model of what's happening with your business or with anything, what we do is we try and say, hey, does that look like a line? Does it look like a parabola? Does it look like a polynomial, a rational function, an exponential function, a logarithmic function? Like, which one does it look like? All right? So I think to try and illustrate polynomial, does anybody, you all know what the stock market is, right? Stock market is, if you look at it, right, if you were to try and describe that graph to me, would it look like a line to you? It looks like this? What's that? Like that? Wavy. Like wavy, right? But it's kind of unpredictable at the same time. It's like it goes up and down and up and down and up and down, and right? It's just doing, generally there's a trend that it does go up over a long period of time, but it can't have major drops and whatever, right? So this is kind of a graph of the stock market. That is not a line, right? And that is not a quadratic, because quadratics have to look like a U. This is actually a good example of what we call a polynomial function. And it's something that has a bunch of curves and different heights and different low points, right? Polynomials will give us a way of modeling that sort of thing, all right? Rational functions. This is the last one I'm giving an example of. We'll do exponential and logarithmic later. Rational functions are some of my favorites because I can talk about something kind of cool. Let's see if anyone has ever heard this quote before. This is from a movie, so see if you can name the movie. Ready? Okay. On a long enough timeline, the survival rate for everything drops to 0. Jurassic Park? No. Dr. Seuss? What? No. 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 No one has it, huh? On a long enough timeline, the survival rate for everything drops to 0. Fight Club. It's Fight Club. How many of you have seen Fight Club? Okay. I'm not here to promote the movie. Basically, the main character in the movie is an insurance adjuster for a car company, and he looks at accidents and tries to figure out mathematically formulas to figure out whether or not they're going to make a recall, like do a recall on the car, if they're just going to continue to let people get hurt with defective cars. But I've always liked that line. I'll say it again. On a long enough timeline. Okay, so here's a graph and here's time, okay? So the quote says, on a long enough timeline, so if you draw this timeline out far enough, the survival rate for everything drops to 0. So let's think about just human beings in general. When a human being is born, right, and they're considered to be alive at some point, right? You're born, you're alive. Yes? Let's start at that. You're living. So at time 0, the probability that you're alive is like 100% because you're alive, all right? And then what happens? You start living, right? And maybe in the beginning, because getting through the first couple of months is sometimes a little risky for babies. They have to get through a lot of things. So maybe, the probability of being alive initially drops a little bit, but then, it starts to get a little better. But what happens as time goes on? Maybe after the first year, it's a pretty good chance that the kid's still alive, right? Okay. I mean, in general, right? On a long enough timeline, though, the survival rate for everything drops to 0, meaning that this graph is going to continually, over time, decrease, right? So what's the probability that they'll live to be, now this isn't going to be at a scale, but what's the probability that a person will live to 50? Pretty good, right? I mean, Americans live a little longer than a lot of people. I don't know why. We eat terribly and do everything else bad, but 50, pretty good. You feel pretty good you're going to see 50? Yeah.
Sure.
Okay, and now if I continue this timeline, right, on a long enough timeline, so what about back here to 100? What do you think? Pretty small probability? I mean, okay. All right, so is that graph, you agree with that graph pretty well?